Hello friends, welcome to my channel, myself Parag Jambulkar. In last video, we have seen what is parallel computing, what is the need of parallel computing, limitations of parallel computing, and some applications of parallel computing. In this video, we will see different categories of parallel computing. But before that, we will see here is a memory. Memory, there are different sections are there. One is a data section and another is code section. From code section, instructions are fetched, while from data sections, data is given. Now we have processing unit, that is also called a processing element. It actually performs the operations, that is called as a processing element. And there is one more element or one more unit, that is called as a control unit. So from data section, data is given to the processing element. It is also given processing element will do some operation and that some output will be again returned back to the memory. This is the memory. In the same way, from code section, so control unit will form the stream or queues. So control unit takes instruction from the code section. That instruction will be taken from code section to the control unit, and from control unit that instruction will be given to the processing element. So here we get instruction and here we will get the data. So this we call instruction stream, while we call data stream. Stream means collection of bytes. So instruction stream, so you will get from control unit, and control unit will get from code section of memory, while data will be given by data section of memory, and processing element will do the operation, and whatever the output that you will get, that output again is returned back to the memory. There are four major categories. Single instruction, single data is also written as SISD. Single instruction, multiple data. Multiple instruction, single data. Multiple instruction, multiple data. So it is also called as Flynn's taxonomy. Out of these four categories, this is the serial one, while these three categories are the parallel system. Now we will look this diagram. So same thing, whatever we have written here, so here we have written in tabular format. Simplest one is single instruction, single data. So this is a processing element, memory unit. So data section of memory unit, we get data stream that is given to the processing element. Control unit will take instruction from the memory. So here is the instruction stream, data stream will do the operation, and again it is returned back to the memory. So one instruction and one data. Now second one is single instruction, multiple data. So single instruction, again that will be taken by control unit and it will be taken from the memory. Now here there is a multiple data. So for example, we have z is equal to x plus y, that is a single instruction, but you can do it for 3 and 2, 5 and 6, 7 and 3, like that. So for x and y, we can have the multiple values. So we can have multiple data, but we have the same instruction. So same instruction will be executed by this processing element, but for that each time we are getting the different data. While multiple instruction, single data is a different one. For example, we have sin x plus cos x plus tan x. Now here we are giving the same data, same x, but here is the sin operation, here is the cos operation, here is the tan operation. So here same data will be provided, while there will be multiple instructions. Different instructions will be there, and those instructions are fetched from the memory. So control unit will take instructions from the memory, and that will be given to the processing unit, processing elements, and processing elements will take same data from the memory. It will execute and again it will return back to the memory. Why there is a two arrow? Because here is the input to the processor and another is output. So output from this will be given back to the memory. Last one is multiple instruction, multiple data. So here there are multiple instructions and for that there is a various data, multiple data is there. So that's why it is called as multiple instruction, multiple data. Again same way. Processing elements taking instruction from the control unit taking instructions from the memory, while processing elements taking data from the memory. MIMD parallel system is again categorized as shared memory MIMD and distributed memory MIMD. Shared memory MIMD is also called as tightly coupled multiprocessor system, while distributed memory MIMD is also called as loosely coupled multiprocessor system. Now what is the difference? Here different processing elements, they share the common memory, or we can say it is a common global memory. So global memory is shared by all the processing element, while here for each processing element they have the local memory. So this memory is particular to this memory is particular to this, and this memory is particular to this. Now as all the processing elements they are sharing the common memory, so communication in between these processing elements is through the common memory. So communication is through the shared memory or global memory, while there is no common memory for processing element in distributed memory MIMD. So communication between these is through the interconnection network or bus. So here communication is through interconnection network or bus. Now here there are more chances of getting faults. For example, suppose fault we got in memory, and all the processing elements they are sharing the common memory. So any fault we get, that fault will get replayed back to the all processing element. But that is not case here. Here each processing elements has its different memory. So suppose fault occurs in that, so it is not going to affect on other processing elements or other systems. Now, so that's why it is called a less tolerant. Means there are more chances of faults. So that's why it is less tolerant to the failures, while it is a more tolerant to the failures. That more tolerant in the sense there are less chances of failures. It is less scalable. Less scalable why? Because all the processor they are sharing the common memory. So there are limited number of processing elements can be attached to the same memory. While here all are independent. So you can add any number of processing elements along with their local memory. So that's why this is less scalable, while these are more scalable. More scalable in the sense you can add more processing elements here, while less scalable in the sense you can add less number of processing elements here. So friends, I hope you like this video. If yes, then click on like, subscribe to the channel and don't forget to press the bell icon so that you will get notifications of my next video. So stay connected. Thank you.